Welcome back to Broken to Built. Today we're facing a tool failure that would stop most industrial workshops in their tracks. We have a high-torque, heavy-duty air impact socket that has completely sheared its sidewall. These sockets are engineered from chrome molybdenum steel to handle extreme vibration, but even the toughest alloys have a breaking point. When the wall of a socket this size fails, it's usually considered a total loss. However, we're going to engineer a custom structural jacket to encapsulate the fracture and return this tool to the front line. Our first task is to stabilize the fractured halves. We're mounting the broken socket in the 3-jaw chuck to begin truing the outer diameter. We aren't just cleaning the surface, we are removing precisely enough material to create a perfectly concentric landing for our reinforcement sleeve. By truing the outer wall, we ensure that the new jacket will sit with zero tolerance. This is essential for the even distribution of the massive oscillating torque loads this socket will face in the field. Even a minor misalignment here would lead to another catastrophic failure under pressure. With the socket prepared, we shift our focus to the reinforcement sleeve itself. We start with a high-carbon steel billet, selected for its high tensile strength and resistance to deformation. On the lathe, we are boring the internal diameter to match the socket we just trued. This is high-stakes precision work. We are aiming for an interference fit, specifically a shrink fit. This requires machining the internal diameter of the sleeve to be slightly smaller than the outer diameter of the socket. It's a game of microns where the math has to be perfect. Now for the most critical part of the engineering process. We use a torch to heat the new steel sleeve to approximately 300 degrees C. As the metal reaches the correct thermal threshold, the molecules expand, temporarily widening the internal diameter. Once the sleeve has expanded sufficiently, we press the shattered socket into the red-hot jacket. As the sleeve cools and the metal contracts, it exerts thousands of pounds of radial pressure inward. This thermal locking effectively fuses the broken halves back together, creating a pre-stressed bond that is arguably stronger than the original solid wall. To ensure this repair is permanent and can withstand the violent hammer action of an impact wrench, we move to the welding bench. We're laying down a deep penetration bead around the interface where the socket meets the new sleeve. We're using a specific ferro rod to bridge the gap between the high-carbon sleeve and the chrome moly body. This creates a unified metallurgical structure. We're not just joining two parts, we are creating a single over-engineered unit that is built to absorb the shockwaves of industrial-scale torque. Once the assembly has slowly air-cooled, we return it to the lathe for the final pass. We machine away the excess weld material and taper the edges of the new sleeve. This ensures the socket maintains a slim profile for better clearance in tight engine bays. We finish by truing the drive face and polishing the steel to a professional standard. What you see now is a reinforced, overbuilt socket that has been resurrected through the power of physics and machining. The transformation is complete. What was once a dangerous piece of jagged scrap is now a heavy-duty, professional-grade tool ready for another decade of service. At Broken to Built, we don't just fix tools, we re-engineer them for survival. If you respect the art of the master machinist and the logic of heavy engineering, hit that subscribe button and join the workshop. We'll see you in the next build.